Okay, so I have created a sample rough draft and calculation sheet. So to give you a better idea of what I'm looking for in this project. So hopefully you've gotten a long way already on this and don't have a whole lot of questions. But remembering that the spaces that are in the project outline are minimum spaces and you can go over. You shouldn't worry too much about whether you're really close to the number of square feet required for that animal, as long as you're able to go over. So here is my 10-foot wide walkway, and how do I know it's 10 feet? There's my scale of 5 feet. So 2 squares wide would be 10 feet, and my 20-foot by 60-foot zookeeper's area. Notice that my 6 animal enclosures all wrap around that zookeeper's area. They all touch each other so that nobody can get into the zookeeper's area, so they all share borders. And remember that also that 5 of these areas need to be polygons, and the 6th one is the animal of your choice, and that one's going to have an irregular shape that you're going to use Pick's formula on. So I just started creating shapes. I knew I wanted the elephant to be in a rectangular enclosure just because it's easier to get that 10-foot wide moat around it if I have a rectangle. So again, that's my 1 4-sided figure, and the other ones have a different number of sides. So that's just a rough draft. And I kind of looked at it to say, I think I have enough area for each of the animals, but if not, I can go back and I could, if I needed to make this side longer to give the buffalo more space, I could have changed it easily to something like this in order to give it more space. But then the part that I am going to work on and spend a lot of time on is grading the area. So what you're going to do is you're going to take each one of these animal enclosures and you're going to copy it onto a separate sheet of grid paper. And yes, it has to be grid paper. And you're going to show me how you get the area of that shape. So there's that rhino enclosure. So I copied it down. I counted the number of sides. It has 10 sides. And I just counted spaces. I said, okay, well, let's see. The rhino enclosure has so many spaces in this direction, and 3 spaces down, and 3 spaces over, and so many spaces that way. And I recreated it on a separate sheet of graph paper. And then I broke it up to show how I could calculate the area of this rhino enclosure, remembering that the rhino enclosure has to have 2 areas of pool that are at least 100 square feet each for the rhinos. Those end up being 300 square feet each when you calculate it. So it's fine. It's way over the 100 square feet that are required. The total land area is way over the 500 square feet that was required. So I'm good. And that's the shape of the rhino enclosure, and that's the total area for the rhinos with 600 square feet of water and 1,400 square feet of land. And it has 10 sides. And I came up here and I looked at my buffalo enclosure and I recreated it. 1 space up, 4 spaces over, 2 spaces up, so on and so forth. So I recreated the buffalo enclosure here. It has 8 sides, and because it was such a weird shape, I had to break it into several different polygons to get the area. And this time, in order to make it a little bit neater, I just numbered the polygons and then got the area, the total area of each polygon, and then added all those up to get the area of the buffaloes needed. So you have 6 enclosures. So for each one of those enclosures, you're going to redraw the enclosure, and you are going to break that enclosure up into rectangles and squares. And there's the elephant one that was a rectangle. I calculated the area without the moat, but then I also calculated the area with the moat. We are going to need that later for the speck of dust calculations. My extra animal I decided were ocelots, and I used Pick's formula on it. Remember that Pick's formula is half of the boundary points, and I counted 24 boundary points plus the interior points, and I counted 96 interior points. minus 1, that gave me 107 square units. But then I needed to multiply by 25 because each square unit is 25 square feet. And that gave me the total area of the ocelots. Now, if you're counting boundary points and interior points, remember we did it originally on dot paper. So if it was on dot paper, each one of these intersections of the grid coordinates, that would be considered a dot. So that's how you count that. There's my giraffe space. And then I did my hippo space, and that one's a 12-sided one, and I showed you how much of the space ended up being water, because I ended up with a total of 1,350 square feet for water and land. 300 square feet of that was land, 1,050 square feet of that total was water. So I just make a ratio of water area over total area, ended up as 0.777 repeating, which when you multiply by 100 to make it a percent gives you 77.77 repeating percent. And remember, the percent of water needs to be 75 to 80% of the total. Now, one of the things, when I created the hippo enclosure, I tried to make sure that I put the land area where it was touching the zookeeper's enclosure so that the zookeeper could go in and do anything he needed to do or she needed to do to, you don't want him to go swimming through the hippo enclosure to give them food and stuff like that, or do whatever he has to do or she has to do. All right, so that's it. I have another short little video about the speck of dust and probability calculations later on. Bye.